Have you ever wondered what happens to satellites when they die, or how their ghostly remnants could be affecting our planet's magnetic core? Welcome to the world above our heads, a world filled not only with the shining stars and celestial bodies that we admire from afar, but also with space debris. Among these celestial cast-offs, dead satellites constitute a significant portion. Once they've completed their mission, these satellites don't just disappear. They become dormant, lifeless structures that continue to orbit our planet, like ghost ships adrift in the sea of space. This is the fate of all satellites, whether they were used for weather forecasting, communication, or scientific research. Now you might be wondering, what's the big deal? They're just floating around up there, right? Well, not quite. The truth is that these dead satellites present a couple of significant challenges. First, there's the risk of collision. As these defunct satellites orbit the Earth, they run the risk of colliding with operational satellites and even with the International Space Station. Imagine driving down a highway filled with abandoned cars. That's the situation our operational satellites and astronauts have to navigate through every day. But there's another, less obvious danger these dead satellites pose. They can affect the Earth's magnetic core. Yes, you heard that right. These metallic structures, floating hundreds of miles above us, can influence the Earth's magnetic field, the invisible force that protects us from solar radiation and helps birds navigate their migratory routes. So, we've established that dead satellites present a dual challenge. They pose a risk of collision, and they can affect our Earth's magnetic core. But how exactly does this happen? Let's delve deeper into this cosmic conundrum. You might be wondering how a piece of man-made metal floating in space could possibly affect the Earth's magnetic core. It's a fascinating process. Let's dive into it. Think of Earth's magnetic field as an invisible shield, a protective barrier that extends thousands of miles into space. It's generated by the swirling molten iron in Earth's outer core, creating a dynamo effect. This shield is our defense against the harmful solar winds and cosmic rays, and it also keeps our compasses pointing north. Now let's consider the dead satellites. These are essentially huge chunks of metal, left to orbit our planet indefinitely. And, as any physics enthusiast will tell you, metal can interact with magnetic fields. When these satellites pass through Earth's magnetic field, they can cause little ripples and disturbances. While these changes are relatively subtle, over time, with thousands of satellites orbiting our planet, they could add up, potentially affecting the stability of our magnetic field. The consequences of such changes are not entirely understood yet, but we do know that the magnetic field has a pivotal role in keeping our planet safe and habitable. So, any potential instability could have far-reaching effects. So, the dead satellites are not just a space traffic hazard, they are also meddling with our magnetic field. But can we do something about it? The issue of space debris, particularly dead satellites, is a pressing one, but fear not, scientists and engineers are working on solutions. Our future in space depends on our ability to manage the clutter we've left behind. One solution is the development of technologies for safely deorbiting satellites once they've reached the end of their operational lives. Imagine a satellite functioning like a space-age garbage truck, equipped with the tools to guide defunct satellites back into the Earth's atmosphere, where they would burn up harmlessly before hitting the ground. But what if we could do more than just dispose of these space relics? Here's where innovative ideas like space debris recycling come into play. Think about a future where we have the capacity to harvest and repurpose these materials right there in the cosmos, reducing the need for launching new materials from Earth. And then there are concepts of space debris removal. Picture giant space nets, or even lasers, used to sweep up or vaporize smaller debris pieces that pose threats to operational satellites. These efforts are not just about tidying up space, they're about preserving the integrity of Earth's magnetic core. By reducing the amount of metallic debris in space, we decrease the interference with the magnetic field that protects our planet. While the problem of space debris is a complex one, with continued innovation and responsible practices, we can prevent further damage to our planet's magnetic core. Space, the final frontier, could be our next landfill if we aren't careful. Please click the like button and stay tuned for more stimulating news.